Okay, so once again, good morning everyone, and thank you for attending our class. So our topic for today is about, of course, UML, Dynamic Modeling Notation. So, of course, uh, we have a semantic comprehension of three different notations for representing the dynamic behavior in unified modeling language. Specifically, of course, focus on sequence diagrams, collaborations, and state diagrams. So, the UML notation is more comprehensible when the dynamic behavior is modeled in a sequence diagram. So while it is implemented using a collaboration diagram, the design turns out to be less comprehensible as the application domain and consequently the document is more complex. As what we defined last meeting based on our presenter, that UML is a standard language for specifying, visualizing, constructing, and documenting the artifacts of software system. So again, I just want to reiterate that the UML was created by the Object Management Group and UML 1.0 specification draft was proposed to the Object Management Group in 1997. So the OMG or Object Management Group stated that the UML is different from the other common programming languages such as C++, Java, COBOL, and others. So UML is a pictorial language used to make software blueprints. No? It can be described as general purpose visual modeling language to visualize, specify, construct, and document software system. Although UML is generally used to model software system, it is not limited to the boundaries. So it is also used to model the software system as well. No? So let's say, for example, the process flow in manufacturing unit. So UML is not a programming language, but tools can be used to generate code in various languages using UML diagrams. So UML has a direct relations with object-oriented analysis and design. So after some standardization, UML has become an object management group. Okay, so the main, as what we discussed last meeting, the main goals of the UML is a picture is worth 1,000 words. So these idioms absolutely fits describing UML. So object-oriented concept were introduced much earlier than UML. At that point in time, there were no standard methodologies to organize and consolidate the object-oriented development. It was then that UML came into picture. So there are a number of goals for developing UML, but the most important is to define some general purpose modeling language, which all modelers can be or can use, and it needs to be made simple to understand and use. Again, the UML diagrams are not only made for developers, but also for business users, common people, and anybody interested to understand the system. So the system can be a software or non-software system. Thus, it must be clear that UML is not a development method, rather it accompanies with processes to make it a successful system. So the goal of UML can be defined as simple modeling mechanism to model all possible practical systems in today's complex environment. I'll just simply summarize the discussions of our presenter last meeting. Okay? Now, to start with the discussion, or to share with us an additional input related to a continuation actually of the UML, let us all welcome our presenter for this morning. Go ahead, sir.
Hello, good morning po sir sa introduction. So, good morning everyone. I am Mubarak Dumalotang. Our topic today is about UML, Dynamic Modeling Notation. So, what is UML? As Sir Marmelo said, UML is not a programming language, but it is rather a visual language. So the general purpose of UML is to define a standard way to visualize the system has been designed. So it is quite similar to blueprint in
Barbie mo nawala na.
field of engineering.
Yung binigay ko sa inyo.
So UML diagram used to portray the behavior and structure of a system. It also helps software engineer, businessman, and system architect with modeling, design, and analysis. So UML guides the creation of multiple types of diagrams such as interaction, structure, and behavior. So as what it said, ang UML kasi para siyang blueprint lang talaga kung saan nagkakaroon ng communication for programmer and non-programmer. Para yung idea ni non-programmer, which is ma ma-capture ni programmer. So, the reason why we use UML is simplify complex software design, can also implement OOP like concept that is widely used. So it also make communication more clear and more real. So like I said, people who do not understand code, UML become more important to communicate with non-programmer essential requirements, functionalities, and process of the system. And the last is it integrate the best practices. So there are two types of UML diagram type. We have the structural, which emphasize the static structure of the system using object attributes, operation, and relationship. It includes class diagram and composite structure diagram. On the behavioral diagram, which emphasize dynamic behavior of the system by showing collaboration among objects in changes to the internal states of the object. It also captures dynamic aspect or how objects communicate with each other, how the passage of time affects the system, or what event caused the system to change internal state. So we have the state machine diagram, which is used to map the behavior of a software system. UML state machine diagram can be used to model the behavior of a class, subsystem, a package, or even an entire system. It also called a state chart or state transition diagram. The behavior of state machine diagram, which is it captures the behavior of an entity present in the system. It also used to represent the specific implementation of an elements, and the behavior of system can be modeled using behavioral state machine diagram in OOD or object-oriented analysis and design. So state machine diagram, the protocol of it is this diagram are used to capture the behavior of a protocol. It also represents how state of protocol change concerning the event. It also represents corresponding changes in the system. Uh, State machine diagram do not represent the specific implementation of an element. So state machine diagram, we have an simple state, which is they don't have substrate, and composite state, and this state is type of can have one or more than one substrate. When composite state or with two or more substrate is called an orthogonal state. And the last is we have submachine state. These states are semantically equal to composite states. However, unlike the composite states, we can reuse the submachine state. So here's the notation in symbol inside the state machine diagram. We have the initial state, which is the start. Start symbol is used to indicate the beginning of a state machine diagram. And also, we have the final state symbol, is used to indicate the end of a state machine diagram. And we have an decision box symbol which contain a condition upon the result of an evaluated guard condition. So a new path is taken for program execution. And we have a transition box. The transition box is is a change of one state to another state with which occurred because of some event. A transition can cause change in a state of an object. And the last, we have the state box, which is defined using some condition or statement within the classifier body. It is used to represent any static as well as dynamic situation. So, ito yung example ng state machine diagram. State diagram. So, ito yung initial, which is the initial state and the final state. And we have also the decision box. So, eto siya. In the interaction diagram is mostly focused on message passing and how this message make up one functionality of a system. Interaction diagram are designed to display how the object will realize the particular requirements of a system. The critical component in interaction diagram is lifeline and message. So the reason why we use interaction diagram is we use to observe the dynamic behavior of a system. It also visualizes the communication in sequence of message passing in the system. And the last is represent the structural aspect of various objects in the system. In the interaction diagram, we have the different types. We have the collaboration diagram, sequence diagram, and the last is the timing diagram. Uh, Collaboration diagram are used to show how objects interact to perform the behavior of a particular use case or a part of use case along with sequence diagram. Collaboration are used by designer to define and clarify the roles of the object that perform a particular flow of events of a use case. They are primary source of information used to determining class responsibilities and interface. So the reason why we use collaboration diagram is it supports the identification of the object, such as hence classes that participate in use case. Model collaboration between objects or role that deliver the functionalities of use case and operation. It also model mechanism within the architectural design of the system. It captured interaction that show the message passing between objects and roles within the collaboration. So the last is each message in a collaboration diagram has a sequence number. So here is the notation and symbol of collaboration diagram. Class name or object name, which represent of an object is done by an object symbol with its name and a class underline, which is separated by a colon. And we also have an actor. The actor represents an actor instance occurred in the collaboration diagram. As the invoker of the interaction, if we have several actors inside instance in in the same diagram, let's try keeping them in the periphery of the diagram. We also have the links. The representation of links, which is connect objects and actors, are instance of association. In each link correspond to an association with the class diagram. And the last is we have the message, which represent the communication between objects that convey information with the expectation that activity will issue. In collaboration diagram, a message is shown as labeled arrow placed near a link. So ito yung example niya. This is the object. We have the object name and the class name. And we also have the message, which is have a sequence number and a self link, ito, which is connect each object or classes. Now we have the sequence diagram. Sequence diagram are interaction between objects in a sequential order. The purpose of it in UML is to visualize the sequence of a message flow in the system. The sequence diagram shows the interaction between two lifelines as a time-ordered sequence of events. So the benefit of using SQL diagram are it is used to explore any real application or system. Sequence diagram are used to represent message flow from one object to another object. And the last is sequence diagram are easier to maintain. So here's the notation in symbol of sequence diagram. Also in sequence diagram, we have actors, which represent a type of a role where it interacts with the system and its object. It is important to note here that an actor is always outside the scope of the system. We also have the lifeline, which depict an individual participant in a sequence diagram. So basically, each instance in a sequence diagram is represented by a lifeline. And the last is we have the message, the representation of communication between objects that conveys information with the expectation that activity will issue. In collaboration diagram, a message is shown as labeled arrow placed near a link. Message is also have different categories. Uh, we have the synchronous message, which wait for a reply before the interaction can move forward. We also have the asynchronous, which is does not wait for a reply from the receiver. The interaction moves forward irrespective of the receiver processing the previous message or not. And also we have the create message. Create message is to instantiate a new object in the sequence diagram. Therefore, there are situations when particular message call requires the creation of an object. Also, we have the delete message. Delete message is delete an object when an object is deallocated memory or is destroyed within the system. We use the delete message symbol. It destroyed the occurrence of the object in the system. And also, we have the self message. Some certain scenarios might arise where the object needs to send a message to itself, such as message are called set message and are represented with a U-shaped arrow. We also have reply message, which is show the message being sent from the receiver to the sender. We represent a return or reply message using an open arrowhead with with a dotted line. We also have found message. Found message represents a scenario where an unknown source sends the message. It is represented using an arrow directed towards a lifeline from an endpoint. And the last is the lost message, which represent a scenario where the recipient is not known to the system. It is represented using an arrow directed towards an endpoint from a lifeline. So, ito yung example niya. We have the lifeline 1 and lifeline 2, lifeline 3. And the message have a different categories. We have the message, sub message, reply message, and asynchronous message. And the last in interaction diagram, we have the timing diagram. Diagram are graph that is used to describe the state of a lifeline at any instance of a time. It is used to denote the transformation of an object from one form into another form. Timing diagram does not contain notation as required in the system and collaboration diagram. So the benefit, mali to. Okay, so mali lang yung. So the benefit of timing diagram is you can tell what change an object undergoing during its lifeline. Also, you can tell how object interacts in how one the state of an object affects the other. And the last is timing diagram show how long the certain process takes. From this data, user can know which step in the process take too much time and what needs to be streamlined for the system or a piece of a software to operate more efficiently as a whole. So here is the basic concept of timing diagram. We have an lifeline which represent an individual part of an interaction. So ito yung lifeline. So we have an state or condition timeline. A condition timeline that represent the state of part- participating classifier or testable condition. So in the lifeline, so sa line na to, ito yung nagiging state or condition niya. And we have the duration constraint, which represent a duration interval or the period of a time state or a value must be in a clear effect for. A failed system is one where a state or value which falls over or under the scope of the constraint. So ito yung duration constraint. Now we have the time constraint, which indicates when an event should occur. If an event fails to occur in said time, the system is considered to have failed. So ito siya. Bago siya mag-lifeline. And the last is we have the distraction occurrence, which represent an X symbol mark at the end of the lifeline. Now we have the UML, that software application that some or all of the notation and semantics associated with the UML, which is the industry standard general purpose modeling language for software engineering. A larger number of these computer-aided software engineering tools for UML currently exist. So this is the most widely known use are. We have the Lucid Chart, Microsoft Video, Visual Paragame, Star UML, Argo UML. So ito yung uh, karaniwang ginagamit sa pag design ng UML diagram. Itong mga UML tools. So yun lang po. Thank you. So ito po yung reference na pinagkuha.
Okay, so thank you very much, sir. In addition to what our presenter discussed or mentioned, again, the UML dynamic modeling notations, describing the modeling language used to define dynamic behavior of a system. So, I think that since majority of us are in line with IT, that is what we call the state charts, no? Or also called state machines. No? A collaboration and sequence diagram, what our presenter mentioned. No? When we say star chart, a state chart, no? In contrast to the class diagram, state charts focus on the dynamic behavior of objects. No? In graphically represent the life history of objects over time and their pattern of intercommunications. No, let's say for example, from the diagram, let's say start from off. No, then we have switch, no? Then we have switch on, and from on we have a switch on process. And that is the
Sir, excuse po, nag-mute po, nag-feedback po kayo, sir. Nag-feedback po kayo, sir.
Okay, so to continue my additional inputs, no? So that is a simple state chart, no? The switch on and switch off. No? We have an off, that's the 0, then 1, no, as our on. Then from off, we have the switch, no? The switch on, and from on to off, the switch off. No? That is the elements of state chart are the states, no? Written and rounded corner boxes, no? This have a name, no? Then the transitions are written and arrows, no? I think that everybody are very much familiar when it comes to a different diagram. Specifically, during our time, no, that our professor always give us some additional, I think, diagrams, no, representing, no, some actions or either process, no? Now, when we say transition, again, written as an arrows from state, and the source of the transition to another. So the target. So they are labeled with the event that causes the transition. Then the default initial state. No? Same with our data flow diagram. No? In every line, there is a certain process, and that is transition. Okay. Now the default initial state. No? The state the object is in the art or at the art of its life history, no? Indicated as the target of a transition arrow which source the initial state, no? Or a black filled circle. So termination of the state chart can be also a bullseye symbol. No? Now, the UML divides state charts into two kinds. No? The number one is of course the proto-state machine, no? Which describe the allowed life history of objects of a particular class in the post conditions. No? And any addition to any are defined in the class diagram. Implicitly, the transition, precondition is conjoined to that of the operations for the given starting state. No? Likewise for the post conditions and others. Now, a while ago, our presenter discussed about object diagrams, no, components of the diagrams, how to draw a component diagram is very important. We need to understand how we will be able to use a UML diagram, no? Specifically in software development. No? This will be a good consideration for us to easily understand and design our software or our system. No? So it is also important to us to understand where to use component diagram because we have already described the component diagram are used to visualize the static implementation view of a system. So component diagrams are a special type of UML diagrams used for different purposes. No? The component diagram covered the model for the component system, the model for the database schema, the model that the executable application, and the system source codes. No? Source codes. No? Then we have also the UML deployment diagrams. Of course, considering the useful for system engineers. No? An efficient deployment diagram is very important as it controls the performance, scalability, maintainability, and portability. So before drawing a deployment diagram, the following artifacts should be identified: the nodes and the relationship among nodes. No? Okay, so then we are all familiar also in doing a use case diagram. Because in our software development, we are required to present a use case diagram. And of course, there's certain interaction diagrams, no? Sequence, collaborations, and interaction. So, as I mentioned earlier, the state chart diagrams, the name of the diagram itself clarifies the purpose of the diagram and other details. It describes different state of component in a system, and the state are specific to component object of a system. So, a state chart diagram describes a state machine, as I mentioned. So, the state machine can be defined as machine which define different states of an object, and these states are controlled by internal or external events. So, activity diagram explain a special kind of state chart diagram. No? As state chart diagram defines the states, it uses to model the lifetime of the object. So, again, as I mentioned, the main purpose of the state chart diagrams is to model the dynamic of the system, as what our presenter mentioned, the lifetime of the active system, different state of an object during its lifetime, and define a state machine to model the state of the object. So, maybe somebody asking, what will be the main usage of the state chart diagram? So, the model the object state of the system. So, the model the reactive system also, and identify the events responsible for state changes or forward and reverse engineering. So, when it comes to UML activity diagrams, it can draw the activity flow of a system. It can describe also a sequence from one activity to another, and describe parallel branch and concurrent flow of the system. So, before drawing the activity diagram, we should identify the activities, the association, the condition, and the constraint. And of course, the four main activities of the diagram is the send order by the customer. Let's say, for example, receive the order, confirm the order, and dispatch the order. As an example of a use activity diagram. So, the activity diagram can be used also for modeling workflow by using activities, modeling business requirements, high-level understanding of system functionalities, and investigating business requirements at a later stage. Okay, so I think that's it for the topic. Thank you to our presenter.